Welcome to another unit in business mathematics. This time I'm going to talk about Lagrange multipliers and how we can use Lagrange multipliers to find potential extrema for functions which are limited by other restrictions, equations, or constraints. When we talk about the process or the procedure of using Lagrange multipliers, what we mean is we have an objective function with a certain number of variables, and we have one or more constraints. Constraints that can be any type of function, however, needs to be an equality constraint. So it should read like either this function g is equal to 0 or to any specific other expression, but it needs to be an equality. If you have inequalities, that's where you use something like simplex. Lagrange works only with equalities. And that's also the first important step to take. When you have your objective function f and your constraints g, first reformulate all constraints that they read as equal to 0. So bring everything, all variables, all parameters, all numbers to one side of the equation so that it reads equal to 0. That's like the first part. And then build the Lagrange function. That's actually pretty straightforward. You take the original objective function. That's the first part. That's here, the function f, the original objective function. Then we insert a new Lagrange multiplier, that's here the lambda, for each constraint. So here we only have one constraint, so we have one lambda, one multiplier, which enters the Lagrange function also as a variable here. If we were to have two constraints, we would have, for example, lambda 1, then plus lambda 2, and then the second constraint. Then we would have two additional variables here. If we want to include the constraints, it's actually here, the multiplier, multiplied with the function. And that's the important aspect. If we introduce it as is here, needs to read equal to 0. Because this would mean we're basically adding nothing here. And well, once we've done this, we're basically good to go, because the only thing we do now is proceed as we would have done for normal extrema, or for finding potential extrema of a function with more than one variable. And we do this process regarding the Lagrange function. So when we start, the first thing we do, as mentioned before, we generate our Lagrange function. We take the first derivatives of this Lagrange function regarding all variables and all multipliers, and we set those derivatives equal to 0. The actually interesting thing to note is if we set all derivatives regarding the multipliers to 0, what we get are again the original constraints. So in this case, we have one equation for each of the variables, one equation for each of the constraints. We set, as I said, them equal to 0, and then we get a system of equations. If it's linear, it's actually pretty easy and straightforward. If it's not linear, at least there's one way how you can proceed in more or less a simple fashion. And that's if you follow these three steps. First, get rid of the multipliers, except if you actually need to determine them. If you don't need to determine them in detail, you can just solve for them, insert the results in any of the other equations, and you got rid of them, so you have one or two or somewhat less variables to consider. this process especially works relatively well if you only have two variables and one constraint. Because in this case, you can actually solve the first derivatives for the two variables for the multiplier, equalize them, and the result you then solve for one of the two variables and insert this into the constraint, giving you the result for the remaining variable. So that's a pretty straightforward, pretty structured way to actually find your solution. The only thing to keep in mind here is whenever you divide by a variable, check first what happens if it becomes 0. So do like a case-wise distinction. Start with variable 0, check what happens, then go variable is different from 0, what happens in this case? Well, that's basically all there is, everything you need to find potential extrema. So there's only one, or let's say 2 steps left. First, you need to check for feasibility of the solutions. It's in brackets because usually we are not doing this here in this course. But if you want to do this, you can get the second derivatives of the original objective function. You get the Hesse matrix. And in this Hesse matrix, you can insert your solutions. Then you calculate the rank of this matrix. If this rank is full rank, then you have a valid solution, a feasible solution. If it's not, then it's an infeasible solution and you're not allowed to consider it further. That's like the 4th step. And then we could, if we wanted to, add an additional step because we only have potential extrema here. So we also have to check how they compare to each other and to my border values, my limits. And only then can I actually say something about their nature as local, global, minima or maxima. Well, once you've done this, you are actually finished with determining your solutions. And well, that's then everything there is to Lagrange multipliers. So I hope you enjoyed this short session, and I say goodbye and see you next time.